Today we're diving into something that almost sounds like science fiction.
Yeah.
Using the tech behind those AI chatbots to predict the future.
Mm,
We're talking about time series forecasting,
right.
which is basically used to track things over time.
Okay.
Things like sales figures or energy consumption
Yeah,
or stock prices.
sure.
It's really used everywhere,
Yeah.
from retail and finance to healthcare and climate science.
I see.
And this new model called Chronos is really
Yeah.
kind of changing the game.
So for a long time, we relied on these traditional statistical models for this kind of forecasting.
Right.
But in recent years, deep learning models have taken over,
Yeah,
offering a lot more power and flexibility.
I see.
However, even these advanced models have limitations.
Okay, so the researchers behind Chronos saw an opportunity
Okay.
to take things even further.
Mm.
They wanted to develop a model that could handle huge data sets,
Yeah.
but also make accurate forecasts on data it had never encountered before,
Oh, wow.
what they call zero-shot forecasting.
Interesting.
And the interesting thing is,
Yeah.
Chronos gets inspiration from the world of language models.
Mm.
Those same AI systems that power things like chatbots and text generators.
Okay.
But applying this tech to numerical data presents a challenge.
Oh, how so?
Well, language models work with words,
Right.
which are drawn from a finite vocabulary.
I see.
Time series data, on the other hand,
Yeah.
it's made up of continuous numbers.
Oh.
There's like an infinite range of possibilities.
So how do you
Yeah.
bridge that gap?
Yeah, so how do you teach a model designed for words to understand and predict numbers?
So Chronos uses a technique that involves converting these continuous numbers into something more like words.
Okay.
Think of a histogram.
Right.
Those bar charts that group data into ranges or bins.
Okay.
Chronos takes the entire range of possible values in a time series
Yeah.
and divides it into these bins.
Okay.
Each bin is then assigned a token, kind of like giving it a label.
Yep.
From there, Chronos predicts the sequence of these tokens, essentially forecasting by classifying the values into the right bins.
So instead of predicting the exact numbers,
Right.
Chronos is predicting which category or bin those numbers will fall into.
Exactly.
It seems counterintuitive
Yeah.
that this would lead to accurate forecasts.
It might seem like taking a step back,
Yeah.
but this tokenization process actually unlocks a lot of flexibility.
Hmm.
It allows Chronos to learn a variety of complex patterns in the data,
I see.
even those with multiple peaks or trends.
So this tokenization process is really central to Chronos' design.
It is.
But these models are known for needing tons of data to train effectively.
Yeah.
Where did they find all this information?
That's a real challenge.
Yeah.
In the world of time series data,
Hmm.
we don't have the same abundance of publicly available time series data that we have for text. Like all those books and articles on the internet.
Oh, I see.
To overcome this, the researchers behind Chronos turned to some creative data augmentation techniques.
Data augmentation.
Yeah.
That sounds like they're stretching their data set somehow. Can you give us an example?
One technique they use is called TS mix-up.
Oh,
It takes real-time series data from different data sets
yeah.
and blends them together, almost like mixing paint colors to create new shades.
Okay.
This creates hybrid time series
I see.
that expose Chronos to a wider range of potential patterns.
So they're essentially creating synthetic data points to supplement the real data.
Yeah.
What other tricks did they use to expand their training set?
They also used a technique called kernel synth,
Okay.
which uses mathematical functions to generate completely synthetic time series data. This adds even more diversity to the training data,
I see.
ensuring that Chronos isn't limited to the patterns found in the real-world datasets.
Training a model on both real and synthetic data.
Right.
I'm sure that raises questions about how well it actually performs.
It does.
What kind of results did they see?
The results have been impressive.
Oh, wow.
Chronos outperforms many existing forecasting models, both when using data it has seen before,
Yeah.
and more importantly, when making forecasts on completely new data.
Being able to accurately forecast on unseen data
Right.
sounds like a major breakthrough.
Yeah,
With big implications for various fields.
definitely.
Did they dig into why Chronos performed so well?
They investigated a number of factors,
Okay.
including the size of the model,
Uh-huh.
the amount of training data used,
Right.
and the length of historical data provided to the model.
Okay.
Interestingly, they found that adding a small amount of synthetic data to the training mix actually boosted performance.
That's counterintuitive.
It is.
Fake data helping a model make better predictions.
Right.
Is there an optimal amount of synthetic data to use?
Their research suggests there's a sweet spot.
Right.
While a small amount of synthetic data helped,
Yeah.
too much actually started to degrade performance.
Mm.
It's a balance between exposing the model to a wider range of patterns and keeping it grounded in the real world.
It sounds like they put Chronos through its paces,
They did.
testing its limits.
Yeah.
What other insights did they gain about the model's performance?
They discovered that providing Chronos with more historical data generally leads to better accuracy.
Okay.
But only up to a certain point, after a certain threshold, adding more data didn't seem to make much of a difference.
So there's a limit to how much historical data is actually helpful.
There is.
That makes sense.
Yeah.
There's only so far back in time you need to go to understand the relevant patterns.
Right.
But I'm curious,
Yeah.
are there any downsides to Chronos' unique approach? This
Yeah.
tokenization process,
Yeah.
does it have any limitations?
There are some inherent limitations to the way Chronos divides the data into those bins,
Okay.
the size of those bins,
Yeah.
and how the data is scaled before it's tokenized can actually affect how precise the forecasts are.
So there's a trade-off between the model's flexibility and the level of detail it can capture.
Exactly.
And what situations might this loss of precision be a problem?
This loss of detail can be an issue when dealing with data that has a very large range of values or very subtle variations.
I see.
In those cases, the tokenization process might oversimplify the data.
So it's like trying to fit a square peg into a round hole.
Right.
The data might not perfectly align with the bins,
Yeah.
and some information is inevitably lost.
How did the researchers try to address this? They developed some clever techniques to mitigate this issue.
Okay.
For example, Chronos can dynamically switch between different normalization techniques, ways of scaling the data,
I see.
depending on the specific characteristics of the time series it's trying to forecast.
So Chronos has a toolbox of different scaling techniques
Right.
and can choose the best one for the job based on the data it's given.
Yeah.
That's pretty ingenious.
It is.
This adaptability is one of the reasons why Chronos is so promising.
I agree.
It's designed to handle a wide range of time series data,
Yeah.
even those with unique characteristics that might cause problems for other models.
Exactly.
It's remarkable how the researchers have bridged the gap between language models designed for words
Right.
and numerical time series data.
It really highlights the power and flexibility of these AI models.
It does.
And it raises some really interesting questions
Oh, like,
about the potential of language models.
okay.
If they can predict the future of numbers,
Yeah.
what other seemingly unrelated problems could they be applied to? It's a fascinating avenue for future exploration.
It is.
The potential applications are vast. The researchers behind Chronos really dug into how its performance compares to other models,
Okay.
including those specifically designed for certain tasks,
Uh-huh.
and those like Chronos that aim for a more general approach.
So how does Chronos stack up against the competition?
Well, they tested it on two sets of data.
Okay.
One containing data Chronos had seen during training, and another with entirely new datasets to evaluate its zero-shot capabilities. Across both benchmarks, Chronos performed well,
I see.
particularly the larger versions of the model.
So Chronos held its own even when faced with unfamiliar data.
Yeah, in many instances, it even outperformed models specifically designed for the task,
Wow.
particularly in the zero-shot tests.
So that suggests that Chronos could really be a game changer for streamlining forecasting processes,
It could.
eliminating the need to train a separate model for every forecasting task
Right.
would be significant.
The efficiency gains could be transformative,
For businesses and researchers,
for sure.
using a single model trained once on a large and diverse data set
Right.
for a variety of tasks
Yeah.
seems to be a growing trend in AI.
We are seeing this in natural language processing
Uh-huh.
with models like GPT-3,
Right.
and now with Chronos and time series forecasting.
This concept of a foundation model,
Yeah.
adaptable to various applications, is pretty powerful.
It is.
What specific models was Chronos compared against in these benchmarks?
They tested it against a range of models,
Okay.
including some well-known ones in the field,
Ah,
like DeepR,
right.
a model from Amazon that utilizes recurrent neural networks, and NBeats,
Okay.
which is based on an ensemble of simpler forecasting networks.
So those are models specifically designed for time series forecasting.
They are?
Okay, what about
Yeah.
TFT?
Oh, right. TFT, or temporal fusion transformer,
Okay.
which incorporates both deep learning and traditional statistical methods.
Trying to combine the best of both worlds.
Exactly.
Did Chronos outperform all of these?
While not in every instance,
Okay.
it consistently ranked among the top performers,
Mm-hmm.
especially in that zero-shot setting.
Okay.
Even when it didn't achieve the highest score,
Yeah,
it often came very close,
I see.
particularly when compared to those task-specific models.
For at least a strong contender.
For sure.
The researchers highlighted this consistent performance across such diverse data sets as a key strength of Chronos.
Right.
It's not limited to a single type of data or forecasting problem.
Exactly.
You mentioned earlier that the researchers investigated the impact of synthetic data on Chronos's performance.
I did.
What were their findings?
Well, one experiment focused on systematically varying the proportion of synthetic data used during training.
Okay.
Adding a small amount, around 10%,
Yeah.
actually improved Chronos's performance
Really?
in both in-domain and zero-shot scenarios.
So a little bit of fake data can be beneficial.
It seems that way. The synthetic data, while not real-world information,
Right.
helps Chronos learn a broader range of patterns,
Right.
enhancing its adaptability and robustness.
Like providing it with extra practice problems,
Yeah.
even if they're not from a real textbook.
Right.
But was there a point where this synthetic data became detrimental?
They observed that exceeding that 10% sweet spot led to a decline in accuracy.
So a balance must be struck. It must.
Too little synthetic data may limit its ability to generalize,
Yeah.
while too much might cause it to lose its grasp on real-world patterns.
Exactly.
This underscores the importance of carefully curating and balancing the training data for these models.
It does.
It also highlights the need for more high-quality, publicly available time series data.
Absolutely.
We've discussed Chronos' strengths,
Yeah.
but are there downsides to the tokenization process itself?
Well, the size of the bins Chronos uses to classify values
Hmm.
and the way data is scaled before tokenization can impact the precision of its forecasts.
A trade-off between the model's flexibility
Yeah.
and the level of detail it can capture
Right.
for data with a very large range of values
Oh, yeah.
or very small variations.
Uh-huh.
This tokenization process might result in a loss of granularity.
Like trying to fit a square peg into a round hole.
Yeah.
The data's shape might not align with those bins,
Right.
leading to information loss.
Did the researchers offer any solutions?
They acknowledge this limitation,
Okay. And suggest that users carefully consider how they pre-process data before feeding it to Chronos,
particularly the normalization technique used to scale the data.
Normalization adjusts values to fit within a specific range.
It does.
Okay.
The choice of normalization technique can impact Chronos' ability to capture nuances in the data.
I see.
Certain techniques might be better suited for specific types of data.
So it's about selecting the right tool for the job.
Exactly.
Choosing an appropriate normalization technique can help Chronos produce more accurate forecasts.
Right.
Especially when handling challenging data.
Yeah.
How does Chronos address the common issue of missing data in real-world datasets?
It employs a technique commonly used in language models,
Okay.
filling gaps with a special PA token.
Okay.
It acts as a placeholder indicating a missing value.
So instead of attempting to guess or impute those missing values,
Right?
it simply acknowledges their absence.
Exactly.
This straightforward approach avoids introducing potentially biased assumptions.
Yeah. During training, Chronos learns to manage these PD tokens,
It does.
making predictions even with incomplete information.
That speaks to the model's flexibility and robustness.
It does.
This ability to handle missing data is crucial for real-world applications.
It is. What are some specific examples of how Chronos' capabilities could be utilized in practice?
In retail,
Yeah.
Chronos could forecast demand for specific products,
Okay.
optimizing inventory and reducing waste.
Accurate demand forecasting is critical for retailers,
It is.
especially in today's dynamic environment.
What about other industries?
Yeah.
In the energy sector, Chronos could forecast electricity consumption,
Okay.
assisting power companies in balancing supply and demand for more efficient energy distribution.
In finance,
Yeah.
it could forecast stock prices or other financial indicators,
It could.
providing valuable insights for investors.
Right.
Are there broader implications of Chronos' success?
I think so.
Does it signal a shift in time series forecasting?
Chronos, with its reliance on language models and large data sets, suggests a movement toward more general-purpose, data-driven solutions.
A move away from relying on multiple
specialized models
Right.
toward more adaptable, versatile approaches.
Yeah.
This shift could simplify forecasting processes,
It could.
making them more efficient and accessible,
For sure.
potentially leading to faster innovation
Right.
as researchers build upon these foundation models.
I think that's a very real possibility.
It is remarkable how AI is influencing so many different fields.
It is.
This concept of a foundation model is intriguing.
Mhm.
Train it once, use it for a variety of purposes.
Right.
With Chronos specifically, are there other research teams looking into this idea
Yeah.
of using language models for time series forecasting?
Other researchers are exploring these connections as well. Chronos isn't the only example of this trend.
What are some of the approaches other researchers are exploring in this space?
Some are investigating how to adapt existing language models,
Okay.
like those used in chatbots, to directly handle numerical data
I see.
without requiring this binning or tokenization step.
So eliminating that intermediate step altogether.
Exactly.
What are some of the methods they are employing?
One approach involves treating numbers themselves as a form of language.
Okay.
Instead of converting numbers into tokens,
Right.
they are training language models directly on sequences of numerical data.
That represents a shift from the traditional understanding of language models.
It does.
It demonstrates the adaptability of these models.
For sure.
They can learn patterns from any sequential data,
Right.
not just words.
We've discussed Chronos using this binning technique,
Yeah.
and other researchers attempting to bypass that step entirely.
Right. Are there other avenues being explored?
Another research direction focuses on combining language models with other types of deep learning models
Okay.
that excel at capturing temporal dependencies,
Mm.
the relationships between data points over time.
So creating a hybrid model that leverages the strengths of both language models and these temporal models.
Right.
This approach could potentially result in even more accurate and robust forecasting models,
It could.
especially for complex time series with long-range dependencies.
Definitely.
It is remarkable how much innovation is happening in this field.
Yes.
Researchers are pushing the boundaries of what's possible with time series forecasting.
They are.
You mentioned earlier the need for more high-quality time series data.
I did.
Why is this so crucial?
Large, diverse data sets are essential for training powerful AI models, particularly those aiming to be general purpose, like Chronos.
Right.
The more data a model is exposed to during training,
Yeah,
the better it can learn and generalize to new data it hasn't seen before.
like a student having a wide range of materials to study from.
Exactly.
However, with time series data, we face a scarcity.
We do.
Unlike text data, which is plentiful online,
Right?
high-quality time series data is often proprietary,
Yeah.
costly to acquire,
Mm.
or simply not available.
This presents an obstacle to progress in the field.
It does.
The researchers behind Chronos recognize this,
Okay.
emphasizing the need for a concerted effort to expand the pool of publicly available time series data. They believe this is critical for advancing time series forecasting and realizing its potential.
A call to action for the research community and others.
For sure.
Addressing this data shortage is crucial if we want to continue pushing the boundaries of time series forecasting
It is.
and harness its power to solve real-world problems.
Absolutely.
This has been a fascinating deep dive into Chronos and the future of time series forecasting.
It has been an engaging exploration,
It really has.
highlighting the rapid pace of innovation in AI and
Yeah.
the potential of these technologies.
This deep dive has been incredibly insightful.
I agree.
Until next time.